Max is back for another calibration video, and if you're hanging in there, this is part number 7, and I don't think I used my fingers, but you know, we're on 2 hands now. Part number 7, and this will cover the last 3 steps of the calibration before we hook up the power to drive the RF palette directly. So if you found this video before the other videos, make sure you check out my YouTube channel. This is a multi-video series on calibrating an RF-KIT, which is a KIT amplifier. The model number is the Bravo 26-RF2K+, and it's an amplifier intended for amateur radio, which uses LDMOS devices and a switching power supply. 3 kW switching power supply. So this video will cover steps 13 through 15 in the manual, and as always, big call out to DH3NAB, DL5NAM, DF9QA, and NU6X for some documentation. So I'm hoping this video will not take that long, so we're going to jump right into step number 13 if you've been following the previous videos. And again, this is all for reference. I'm doing it live, but make sure you double check everything if you have one of these amplifiers and you're going through the calibration. So I can't be responsible if you screw things up. I'm just doing this as a service to the amateur community, or those that are interested in this project. I'm just a happy consumer here in Syracuse, Utah, having taken delivery of this kit from Germany, from Reinhardt. So, all right, we'll follow the same routine here, and I'll keep an eye on all the screens here, so hopefully you'll be able to see what's going on. Look at this minimize. We're going to bring the manual up here. So, step number 13. We're going to use the VNC. I'm remoted into the front of the panel there. We're going to use the power meter here so we can drive the amplifier. In my case, it's 30 watts. So what we're doing here is on the front of your amplifier on the 7-inch display, look at my cursor here that I'm wiggling around here on the screen. But there's a meter underneath the forward power meter right here. Now this is kind of cool. So this meter right here will show you how far you're in, like a percentage wise. It's the load on the amplifier based upon the input. So based on the previous calibration steps, if you're using a 13 dB attenuator on the input for the amplifier to achieve 1.5 watts max drive to the RF deck, you need to drive the input of that pad, that 13 dB attenuator pad, at 30 watts. And so in the previous steps we showed the protection that will trip the amplifier if you're right above, you know, right around 30 watts based upon the accuracy of your forward power meter, watt meter. And so we want to have this meter right here, that's this bar right below here, max out just before the protection kicks in. So the manual talks about a couple different screens here, so let me just touch on that. So if we go to the menu and we go to the settings, there's a display. There's standard 2, cross pointer 1 and 2, and standard 1. If we go to standard 1, you'll see the white display here. And so I think I'll use the white display just to, you know, mix it up a little bit here. You might be able to see this. So it's this bar right down here that we're going to be adjusting using R14. So let me pull that screen up here. Let's see, R14. Move this over here so you can see it. We will be adjusting R14. It's right here. So it's on the right side of all the multi-turn pots, kind of in the middle below the group of 5 multi-turn pots. So R14. Excuse me, constantly clearing my throat. There. So R14. And I'll try not to forget that. So set the transceiver to 1.9 megahertz. You can see I'm using the CAD interface right here. The amplifier is turned on, and it doesn't say you have to be set in operate mode. So let's just check that real quick. I'm going to key the amplifier and see. I don't see, since we're not in operate mode, we should be able to go above 30 watts as you'd expect, and that meter isn't showing anything. So okay, I'm going to turn that down, and I don't see that the manual says to go into operate, but it makes sense that we would be in operate. So let's just double check the power drive at 30 watts. We should trip the protection here at 30 watts. And so we're going to kick it up here. And we're just double checking the protection once we hit the 30 watt mark as calibrated in previous steps. And boom, right about just over 30 watts. So I'm going to set this meter right here. Let me reset the amplifier. We're still on standby there. I'll go to operate, and what I'm going to do is I'm going to drive the input on the amplifier up to just under 30 watts, and then we'll adjust R14 to R14 here to adjust this meter over here to its max level. So that's just a percentage of the power input to its max before you trip that protection. Okay, R14 it is. Alright, so I'm in operate. I'm going to key the exciter. We're going to drive it up. You can see down here. And I should get this other monitor on while I'm doing that. On the top there, you'll see me just kind of cruise in there to adjust R14. So again, increasing the drive up to just, I don't want to trip the amplifier, right? I want to get it right below 30 watts. So 8, 9, ooh, right there. So I haven't tripped it, right? So now I'm going to go in there to R14, which is right here, and we should see that, see the meter changing on the screen here. So it was actually a little bit too high, right? So you can even see that the power input right here is right at flipping between 29 and 30 watts there. What we want to do is, I'm adjusting the yellow here. It's going to go up to, it's got a little gray section, and we want, I think it's just touching the adjust R14 until the input power bar graph displays a full scale yellow bar. Yellow bar fills the gray area. Okay, I couldn't remember there. So I wasn't sure if I was supposed to stop at the gray area or keep going. So here I turn it down here. See, there's green showing right there. We want to fill that gray area, right there. See, so that's like you're at 100% drive if we were driving the amplifier. So if I turn the exciter up just a hair more, it should trip again, as we would expect. Boom, tripped. So that's exactly what we wanted to do. We got the input power too high. Press reset, and we will stay in standby here. We're on 1.9 megahertz, and that completes step 13. 2 steps to go before we hook up the actual power input to the RF deck. And I'll try to do another video where I go through and check all the QRR, the high power calibration steps again that are recommended in the calibration manual. So the next step, we need to power, this is critical right here, we need to power down the amplifier, okay? And what we're going to do is we're going to calibrate the controller so it knows the actual amperage that's it needs a reference amperage based upon the idle or bias current going into the LDMOS devices. And let me scroll up here a little bit. And I have a version of the amplifier that has the newer BLF 189 LDMOS devices. And so I will be looking for a current draw when bias is actually applied to the LDMOS devices around 5 amps. And so that's set, quote, quote, at the factory, you know, Reinhardt or whoever the technician is there that sets the bias current. It should be close to 5 amps in my case. If you have an amplifier that has the BLF 188 devices, it'll be somewhere around 3.4. Now, don't get too excited if it's not exactly 5 amps, right? So we're calibrating the current display, so the display matches the current draw that's coming from the amplifier. So back to the VNC application here. I'm actually going to shut the application down. Remotely, I can hit Alt F4 like I was closing out a Windows application, right? Works the same way. And so that's going to shut off the software that is monitoring and controlling the amplifier, and you'll see up here that the fan is now off, and I'm actually going to shut down the Linux operating system on the Raspberry Pi 3. So we're going to shut that down gracefully, and you'll see an error pop up from VNC saying that the connection to the the device I'm controlling with VNC has been gracefully closed, and that window will now shut down. I'm now going to power off the amp, and you should be able to, again, be careful because you got high voltage here on the switch, and if you saw the earlier videos, I pulled the toggle switch out of the front of the amplifier. And so I powered that down there, and you may have heard the relay just click there. And I will now remove the power connector from the back of the amplifier, okay? So just so we want to make sure that power is removed here, because we're going to unhook the positive terminal on the 50 volt input and put a digital multimeter in the amperage mode in line, so we can actually measure the current draw coming out of the 50 volt DC switching power supply. And I hope I remember to get all my monitors screens there set up. So I'm going to put the video up here. I think that'll, or the video, the camera rather, up here. And I don't have power on the amplifier here, so what you'll need, this is a little bit maybe over the top in detail, but you'll need a 7mm little wrench here, and you're going to undo the positive terminal that's coming from the DC power supply, okay? And then we're preparing for step number 14 here. So I'm just going to take the little stainless steel nut off there and the washer, okay? And so now we've removed that positive terminal coming from the DC power supply right here, and I can move that out of the way. That's just a SMA connector clicking against the aluminum there. So now I'm going to make the window a little smaller here. Well, no, I think I can leave it big. I'm going to turn on the camera to the digital multimeter. And so this is important right here. We're going to hook up your digital multimeter into an amp measuring mode, right? So we've got common, stays in common, and then we're going to put it in the, most meters have a 10 amp fused connection for testing either alternating current amperage or DC current amperage. If we left it in the middle one here, since we're going to be drawing a lot more than 400 milliamps of current, would blow a fuse inside the digital multimeter. So make sure you have it in the high current. Again, most of them are 10 amps max. You can probably see that right above my fingernail there. And so you're going to turn on the digital multimeter, and you're going to put it, you can hear it beeping because it knows, I mean, this is a fluke meter. It's saying, hey, you've got the leads hooked up for amperage testing, and so don't be trying to do other testing. We're going to switch it over here to the amperage test, and by default, the fluke is in alternating current amperage test mode. So we need to hit the little function button right here, and we'll see this AC up here. I don't know if you can see that, but there'll be an AC here that switches to DC because we're going to be testing amperage. Let's make sure that focuses a little bit there. So yeah, power is off on the amplifier, okay? I'm now going to take I've got a couple clamping leads here that are going to the amp meter, and we're going to hook, just to kind of show you here what's going on. Let me bend that down a little bit. I'm going to hook the black side on here just to keep the colors pretty. So I'm completing the circuit again, right? So the current and the voltage is now going to pass through right here all the way through the ammeter over here, so it can actually test how much current we're drawing as that current comes back and flows back into the RF deck. All right, and then to keep things going, right, see, then the RF deck has a control cable here, this ribbon cable that goes up to the B26 controller, to where it will measure the amperage that is being drawn from the power supply. Okay, so that should, hopefully that's not clear as mud at all. And so the next thing we need to do here too is we need to turn the bias on. So let me get a little more light up here. So those jumpers early on in the calibration process, if that's going to focus for us. So we're going to move these jumpers here to the front of the amplifier. So this will enable bias voltage to go to the LDMOS devices. So, excuse me, the voltage and the current, right? So that it'll allow the bias, the configured bias current, which was set by these multi-turn pots right here that have been effectively, you know, there's some material, they're sealed right, so you know, Reinhardt doesn't want you tweaking that bias adjustment. So, but that's what those two pots do. So now we have the bias turned on, okay, and so now, so once we key the amplifier, the LDMOS devices will start drawing current, and we'll be able to see how much current is being drawn on the amp meter, and we're not adjusting how much current is being drawn. That's already done at the factory. But I need to pull up the, we need to power on the amplifier again and wait for it to boot up. So I've got to hook the cord back in. Just make sure all your amp meter cords and everything are clear. You do not want that positive ground coming, or positive terminal coming off the power supply making contact with ground. Would be very bad. Power supply can deliver a lot of current at 50 volts, 50 plus volts. So now the power is hooked back up. I'm turning on the amplifier over here. Okay, be careful again, there's voltage. And so now you can actually see the, you probably can't see it through my little cover there, but the Raspberry Pi 3 Plus is booting up. And when that fan comes on, we'll know that it's booted up and we can reconnect to the Linux operating system and the application that started up that Canute has spent a lot of time on. So you can see the fan just kicked on there. All right. I've got those bias jumpers in place there. So now I'm going to fire up VNC, and it's now connected to the amplifier. So we've got down here we've got the digital multimeter in DC amperage testing mode. And what we're going to do, let's just come back here and go through the instructions here. It's very clear that you want to turn the amplifier off. So the B26-PA01 controller is designed to work with 2 different current sensors. Oh, that's a good point. You want to make sure in the menu that the current sensor under hardware is set to the PA module is RF-KIT 2K plus right there. Okay. And oh, by the way, bit of a digression here. You can see that the universal frequency control has been selected, so I can kick it back in to CAT, and there seems to be a little tweak that needs to happen in the software. It'd be nice if it automatically picked up the CAT again when you click on that button, but I've noticed that just for consistency's sake here, I'm going to go to rig control, and we're going to switch it back to CAT, and I'm going to test the CAT, click close, see if it picks it up here, and we go back to CAT. See, sometimes it doesn't pick that up, so that's a bit of a nitpick there. There we go. There, it got it. So there, it just picked up the CAT pulling from my K3S. Anyway, just to be consistent there, we're on 1.9 megahertz here. All right. So insert a digital meter in the positive 50 volt DC lead of the 50 volt DC period. I mean, it's a little unclear there. We could add a little more clarity there in the manual. Alternatively, which is an alternate method, there's DC clamps that you could just clamp around that positive lead to measure amperage. But what I'm doing with inserting the meter right in line with the positive lead there coming from the DC power supply will be the most accurate with a good meter. All right. Just going to the next page on the manual, in big red text here, we need to make sure we move the bias jumpers to the on position because they were off early on in the calibration process. So the on position is 2 pins towards the front of the amplifier, which we have done. I'm going to now kick the amplifier into operate mode, and we're going to key the transceiver with very low power. And so I have it set for 1 watt. I'm going to key it, and then I'll just, here we'll turn the power down, and you'll see the amperage draw now on the amp meter. And so I'm going to, turn that power drive just all the way down as low as I can get it. Okay. So, now you can actually see on my bias adjustment from Germany, when they set the bias at room temperature here, which we're sitting at 34 degrees centigrade approximately, and this is going to go up here because we're applying current now to the RF deck. Those LDMOS devices are drawing current. So as they heat up a little bit, you might see a little less amperage draw. So now it's at 5.8. And when I tested this before, it was right around 5.8. And I think as things heated up, you started to see the amperage draw go down a little bit, which is a nice design. And this will also allow us to test the thermisistors or the thermoresistors for the fans. And so as the RF deck and heatsink heat up, we should see the fans kick on, not only for the power supply and low pass filter, but also the fans on the front of the heatsink and the fan on the rear of the heatsink. So that might take a second. So really though, what we're trying to do here is adjust. We're going to go back into the menu. Actually, not the menu. We stay out of the menu. We, you confirm that all the green lights are on here, right? Everything's keyed up. You can see the LEDs. and the fans just kicked on, so that was good timing there. So you can see, I don't know if you can see that if it were to focus, but you can see both green LEDs are on, the green LEDs on the back. This fan just kicked on here, and it's blowing the right direction, right? You want all the airflow going towards the back of the amplifier. The fan on the front of the heatsink, you know, from the perspective of the front of the amplifier, is on, and you know, you might be able to hear actually the fan is very low, quiet, and the fan on the rear of the amplifier is also spinning. So that's a nice validation of the fan connections. A little bit of digression here, but the two fans are in parallel right here, if you can see my finger poking over here. And then the fan, the 80mm fan is right there, the connection. So you want that polarity correct, and I went over that in detail in earlier videos. So now I pretty much have the amperage correct, right? So if we look, let's finish up this step here, because we're you can now see that the temperature of the RF deck is now at 46 degrees centigrade, and I left it on for quite a while with that bias draw, and it seemed to stick right around 47 with the fans at that speed. And you can feel the air is a little bit warm if you see my arm back here in the back of the amp, but it'll level out, right, because we're only drawing 5.5 amps right now. And the pot to use is R21. Right here, let's pull up the screen, and we are going to adjust, okay, R21. It's the second pot, multi-turn pot down from the group of 5 on the right hand side from the front of the amplifier. And so when I adjust that pot, you're going to see the amperage over here. If you've got my cursor here on the VNC screen, right now it's pretty darn close, right? But I'm gonna adjust it so it's off, but we want to match the current here to what we're seeing on the digital voltmeter right now. And as that deck heats up, you're going to see that amperage draw go down a little bit, but I think we're getting close to where it's stabilized here. So again, R21, second one down. I'm going to come in, and as I adjust this pot, you're going to see that display change. See, it's dropping down or it's going up, right? We want to match what's on the amp meter, which is right now it's 5.484. So 5.4, so it's just, you know, if it's flipping between 4 and 5, because it's, you know, 5.48 still. So there. So now well, maybe just a hair more. And 0.84. No, I'm going to call that good because it's flipping between 5.4 and 5.5. I mean, it doesn't have to be perfect, but you want the controller, right? It needs to know accurately how much current is being drawn from the power supply, so it can go into protected mode if there's too much current draw. And so, you know, that should make sense. And you know, as it heats up there, I just want to make sure 21. Okay, let's just tweak that just one more time. This is overkill, I realize it. So we're going to go down. So now we're down to 4, 5. Okay, I'm happy with that right there. So I'm going to unkey the amplifier now. All the lights turn off, and of course the fans stay on. Very quiet, even at 49 degrees centigrade. So I'm excited about how quiet the fans are in this amplifier. Of course, we expect the temperature to be up here when we start driving the amplifier. Okay, we are done with step 14, so one more step to go. Let's see. And I'm going to do this test here with the amp meter still in line, just for, you know, you might want to power off the amplifier and hook up the connections on the power supply to the RF deck again, but I'm going to finish up here with step number 15 and finish this video. So to read the step number 15, the RF2K Plus RF palette has an onboard current limiter. The factory setting is usually sufficient. The current limiter hardware notifies the controller when the limiter has latched through the spare /R18 pot, which is this pot right here, the third one down, right below the one we just adjusted, which is R21. And we just need to show it as a reading of 1,000. That must be like a kind of a one-to-one reference in the controller, I'm guessing. And so the fans just actually stopped. I don't know if you heard that. We're going to go into the debug screen, and we should see a reading on alpha 3 power current monitor that's close to 1,000, and that is the case. So I'll tweak it a little bit. What the heck? So let's zoom in on this. So it's right here, alpha 3 power current monitor. And you do not have to have the amplifier keyed, but it's the third one, the third pot down. So if we change that third pot, you should see that value right here change, right? See, so there it's going down. So I can go below 1,000, back up 1,000, and so clearly that's like a reference, you know, baseline reference for the bias amperage draw. So then the controller can use that as a baseline for current drawn above that, and you know that should make sense. So we're you know right there, you know, bouncing right at 1,000. So that's good enough for me. All right, and I just, you know, let me, okay, so this is saying to key the amplifier, so we better do that. Okay, so does that value change there? Let me just double check that. It's still right at 1,000, so we key the amplifier. And so there definitely is the amperage draw. The bias amperage is being applied to the LDMOS devices, and so I'm not sure why you need to key the amplifier. I mean, I'll tweak it up again. You can hear the fans came on again, and you can see the amperage. I mean, maybe it's, if you're really anal like I am, you know, when it's kind of idle bias temperature, we'll tweak that back up to right at 1,000. Okay, that's probably going to, I'm guessing that's going to go down as the amperage draw kind of lowers down. So now that we have the amplifier RF deck is at 46 degrees centigrade, we're perfectly fine there. I'm going to unkey the amplifier. There's no RF going to the RF deck anyway. I think they're just recommending that you lower the watt drive on your exciter just because there's no reason to have it on high. So the amperage meter on the front of the display is right around 5.5, and that's what I'm seeing on my ammeter there. So I am a happy camper. So if we scroll down to the next section, we just completed step number 15. There is a comment on one of the bullets, you know, while keeping the transceiver keyed, adjust R18 for a reading of 1,000 on the debug screen. I mean, with my exciter, I can key the amplifier, right? And so I don't know why this step is even in here. If you're keying the amplifier, it should be drawing the bias current. So That might need a little tweak there. Fans are slowing down. And as you can see right here, the very last comment in the calibration manual, enjoy your new RF2K amplifier. And that's from DH3 NAB, Reinhardt. However, this is critical right here. Once this procedure is completed, R19 can be fine-tuned at 1,000 watt level. So that begs to the discussion on the next video. So my next step is I will actually be, if you can see, we've got the RF deck bypassed right here with the temporary jumper. Okay, right here, you know, and so I'll desolder that tacked on jumper there, and we'll be taking the SMA connector right here and removing the temporary SMA connector right here with this one, which then the exciter power will be going directly into the RF deck up on towards the front of the board right here. Okay, and at that point we will have the power, we will have some power, and I'll make another video there. I don't know if I'll get to it tonight, but definitely this weekend, and then we'll be having some fun driving the LDMOS devices up to legal limit power into my big dummy load. And so with that, we'll call this video good. And thanks for watching. Give it a thumbs up, and please be objective in your comments. And I hope to see you for the next video where we'll have power. We'll have we'll finally be at the point where we're delivering some QRO power to our dummy load. And then we'll see if I'm motivated. I'd like to do another video on the CAT control. That becomes very confusing for a lot of guys. And I also have a, let's see, let me grab this. I got my cover back. So I think it's beautiful. The local guy that I had do the powder coating, he did his best to match the W4YN front cover as far as the texture is concerned. It's not quite as shiny, but it has that wrinkle coat. But anyway, I'll do another video with the amplifier completely tidied up and done up, and maybe some of you will be interested in that. So as always, 73, double check everything I've done, double check the manual, make sure you've got the latest everything, the latest image to match whatever's going on. Just use these videos as a reference. If I was waiting for my amplifier, I would have really appreciated something like this, even though I know for some guys this is complete overkill. You do not need all the equipment that I show in the videos. I kind of go on a detailed description of power meters in video number 3, and I know that maybe worried some of the operators or the owners that it would keep guys from buying the amplifier, and I hope that was not my intent. You do not need all this equipment. You need an accurate watt meter, you need an accurate digital multimeter, and you need to know how to use it. You need common sense, and take your time, read the instructions 2 or 3 times, watch the videos, make things easier. If you think I made things too hard, make it easier and do the right thing. So 73 for now, and I'll be back with the QRO testing, and that'll be you know, where hopefully we'll have a big grin on our face. So 73, Max NG7M.